Medians. A median is a section of divided highway that separates the lane in opposing direction. The width of a median is the distance between the edges of the inside lane, including the median shoulder. So the function of a median includes providing a recovery area for out of control vehicle, then separating opposing traffic, then providing stopping area during emergency, then providing storage area for left turning and U-turning vehicle, then providing refuge for pedestrian, then reducing the effect of highlight glare, then the last is providing temporary lane and crossover during maintenance operation. So median can either be raised, flush, or depressed. So raised medians are frequently used in urban arterial streets because they facilitate the control of left turn traffic and intersection by using part of the median width for left turn only lane. Some disadvantages associated with raised median including possible loss of control of the vehicle by the driver if the median is accidentally struck, and they cast a shadow from oncoming headlights, which result in drivers finding it difficult to see the curbs. Flash median are commonly used on urban arterial. They can also be used on freeways, but with a median barrier. To facilitate drainage of surface water, the flash median should be grounded. The practice in urban areas of converting flash median into two-way left turn lane is common, since the capacity of the urban highways is increased while maintaining some features of a median. Depressed median are generally used on freeway and are more effective in draining surface water. A side slope of 6:1 is suggested for depressed median, although a slope of 4:1 may be adequate. So we go to the roadside and median barrier. A median barrier is defined as a longitudinal system used to prevent an errant vehicle from crossing the portions of a divided highway separating the travelway for traffic in opposite direction. Roadside barrier, on the other hand, protected vehicle from obstacle of slope on the roadside. They also may be used to shield pedestrian and properly from the traffic stream. Roadside barrier should be provided whenever conditions exist requiring the protection for vehicle along the side of the road. Median barrier can be composed of cable or post and beam system, or concrete. For major arterial concrete barrier are commonly used because of their low life cycle cost, effective performance, and easy maintenance. So the primary advantage to this barrier shape is that adjacent pavement can be overlaid several times without affecting its performance. Additional information on selecting locating, and designing roadsides and median barriers can be obtained from the HTO or H2 roadside design guide. We go to the curbs and gutters. Curbs are raised structures made of their Portland cement concrete or bituminous concrete road asphalt curbs that are used mainly on urban highways to lighten pavement edges and pedestrian walkway. Curbs are also used to control drainage, improve streets and roads right of way. Curbs can be generally classified as either vertical or sloping. So, in vertical curbs, which may be vertical or nearly vertical, range in height from 6 to 8 with steep sides and are designed to prevent vehicles from leaving the highways. But slope curves are designed so that vehicles can cross them when necessarily. Then the gutter or drainage ditches are usually located on the pavement side of the curve to provide the principal drainage facility from the highways. They are sloped to prevent any hazard to traffic, and they usually have cross slope of 5 to 8% and are 1 to 6 feet wide. Gutters can be designed as V-type sections or as broad, flat, rounded section. So, in this picture, we can see the curves. Then this part is the gutter. Then so in this figure 15.6 is steel back timber guardrails. So guardrails are longitudinal barriers placed on the outside of sharp curves and at sections with high fill. Their main function is to prevent vehicles from leaving the roadways. They are installed on embankment higher than 8 feet and when shoulder slope are greater than 4:1. Shape commonly used including the W-beam and the box beam. The weak post system provides for the post of collapse on impact, with the rail deflecting and absorbing the energy due to impact. Then the sidewalk. Sidewalks are usually provided on roads in urban areas but are uncommon in rural areas. So this picture is a figure 15.7, a single slope concrete median barrier. So this is the single slope concrete median barrier. So we go to the cross slope. Pavement on straight section of 2-lane and multiple lane highways without median are sloped from the middle downward to both sides of the highway. resulting in a traverse or cross slope with a cross-section shape that can be curved, plane, or a combination of the two. A parabola is generally used for curved cross-section, and the highest point of the pavement, called the crown, is slightly rounded with the cross slope increasing towards the pavement edges. So, in this figure, 15.8 is typically highway curves. So, these are the sample. Then, in this part, figure 15.9 is basic cross slope arrangement for divided highways. So, there's a type or a sample. These are two types. Each pavement slope two ways. So, in this part. But in this part is each pavement slope are one way. So, one way and two way. So, and in this figure, 15.10 is a designation of roadside region. Then, next, side slopes. Side slopes are provided on embankment and filled to provide stability for earthworks. They also serve as a safety figure by providing a recovery area for out-of-control vehicle. When being considered as a safety figure, the important section of the cross slope are the hinge point and the foreslope and the toe of the slope, as shown as figure 15.10. So, next, right of way. The right of way is the total land area acquired for the constructions of highway. The width should be significant to accommodate all the elements of the highway cross-section. Any planned widening of the highways and public utilities facilities that will be installed along the highway. In some cases, the side slope may be located outside of the right way on easement area. So we go to the part 2 of this topic, the design of the alignment. The alignment of highway is composed of vertical and horizontal elements. The vertical elements includes straight tangent, highways grades, and parabolic curves that connect these grades. The horizontal alignment includes straight tangent sections of roadway and the circular curves that connect their chains in direction. The design of alignment depends primarily on the design speed selected for highway. The least common alignment is one that takes the form of natural topography. It is not always possible to select the lowest cost alternative because the designer must adhere to certain standard that may not exist on the natural topography. It is important that the alignment of a given section has consist standard to avoid sudden changes in the vertical and horizontal layouts of the highway. It is also important that both horizontal and vertical alignments be designed to complement each other, since this will result in a safer and more attractive highway. One factor that should be considered to achieve compatibility is the proper balancing of the grades of tangents with curvatures of horizontal curves and the location of the horizontal and vertical curves with respect to each other. So in this picture, in table 15.4 is a recommended maximum grades. So you can see the grades of different parts. Then the continuous of the grades is in this side. Then next, vertical part of the second part is the vertical alignment part of the alignment. So the vertical alignment of the highway consists of straight section known as grades or tangent connected by vertical curves. The design of the vertical alignment therefore involves the selections of suitable grades for the tangent sections and the appropriate length of vertical curves. The topography of the area through which the road traverses has a significant impact on the design of vertical alignment. Vertical curves are used to provide a gradual change from one tangent grade to another so that vehicles may ride smoothly as they traverse the highway. These curves are usually parabolic in shape. The expressions developed from minimum length of vertical curves are therefore based on the properties of the parabola. In figure 15.11, stated vertical curves that are classified as crisp or snug. So this is the sample. This is the figure 15.11 types of vertical curves. So you can see it in the book. Then the length of crisp vertical curves, provisions of minimum stopping sight distance or SSD is only criterion used for design of a crisp vertical curve. So in this part we can see the figure 15.11 and figure 15.13. Sight in figure 15.12, sight distance of crisp vertical curves is S is greater than the L, or the sight distance, and L is length of work curves feet. In 15.13, sight distance of crisp vertical curves is opposite from the figure 15.11, but we can see the opposite of the two figure. So for further and more visions for these pictures, we can see it in the book. Then next, so guys, in this slide we can see the figure 15.13 and two possible scenarios that could control the design length. Number one is the SSD is greater than the length of the vertical curves. Then the second is the SSD is less than the length of the vertical curve. So you can see these two possible scenarios in the figure 15.12 and figure 15.13. So consider the case when the SSD is greater than the length of the vertical curves as shown as in the figure 15.12. So going back, consider the case when the SSD is greater than the length of the vertical curves as shown in figure 15.12, where the driver eyes height is in a vehicle on the grade at point C is h sub 1 feet, and the objective of point G sensed by the driver is h sub 2 feet by feet. The driver's lane of sight is Pn feet and the SSD is S feet. The lane of sight Pn may not necessarily be horizontal, but the value used in calculation for SSD consider the horizontal projection from the properties of the parabola. So we have this. Then continue. The SSD or S is this. First, we must follow this step. We have 5 steps we must follow. Also, these steps are in the book, and we go next. We go to the example. So example 15.1. So minimum length of crisp vertical curves. So a crisp vertical curve is to be designed to join plus 3% grade in a negative 2% grade at sections of a 2-lane highway. Determine the minimum length of the curve of the design speed of a highway is 60 miles per hour. So S is less than length, and perception's reactions time of 2.5 seconds. The declarations rate for braking or A is 11.2 feet per second squared. So the solutions is this. Use the equation derived in chapter 3. So we go back to the chapter 3 for us to see the derivation of equation, then to determine the SSD required for the design condition. So since the grade changes constantly on a vertical curves, the worst case value for G of 3% is used to determine the braking distance. So here we go. The SSD is 1.47 plus U is 2 over 3 times A open parenthesis A over 33 32.2 close parenthesis minus the g, then close parenthesis. So substitute all the value, then the answer is 598.1 feet. Then use equation 15.5 to obtain the minimum length of vertical curve. So L length of minimum equals to AS raised to 2 over 2158. Then substitute all the numbers, then the answer is 828.88 feet. We go to the second example. The maximum safe speed on a crescent vertical curve. So the problem is an existing vertical curves on a highway joint, positive 4.4% grade with a negative 4.4 grade. If the length of the curve is 275 feet, what is the maximum safe speed of this curve? So the problem is what speed should be posed if 5 miles per hour increment are used. So assume that A is equal to 11.2 feet per second squared. Perception reaction time is 2.5 seconds, and that is sight or S is less than L. So the solution is this. The continuation is in this part. Before answering this example, we must know first the different parts, then what is needed and the given of the problem. Next, the continuation of the example, the explanation of answer step by step. All of this are in the book or in the PDF that given. Then also example of minimum length of slug vertical curves, the problem and its solution. We can follow it for us to be the next. We go to the